Hola, es 28 de febrero. Es un nuevo día para LeetCode, el reto para LeetCode. Primero vamos a ver algunas noticias. Okay, no, I'm not gonna keep doing this. It's too hard. Alright, nothing in here. Okay, so yesterday we had a bit emergency and we didn't finish very well. So we ended up with a third solution that uses that's very smart by Lee 215. And actually, I'm going to pull it up so just so that we can take a look at the last solution. I was halfway in writing it, but we had an emergency. All right, so this is the third solution. It ran the fastest. So basically, what it does is instead of we incrementing on the divisors, right? Every time we just remove a divisor and then we double the divisor. Either we do doubling or a bit manipulation. We shift right, shift left, like here, like we constantly shifting and then removing the divisor in order to know the quotient, but not doing that. So this method is very smart. It is to check directly how many times we need to double the divisor. How many times the divisor is doubled that can still be taken away from the original dividend, right? So we know that there are only 32 bits, so we can just run a loop for 32 times from the most significant, right? From the most significant to the least significant. So in here, so we start from the 31st, right? So the 31st bit. If you think about the zero, the least significant is on the right side. The most significant, the 31st bit, is going to be on the left side. So we check the divisor. Of course, we divisor and dividend completely positive. We take absolute value. So the dividend, we're gonna shift it right. So when we shift the dividend right, that means we just divided it, right? We divided by shifted by c times, so that's the current count, right? Divided by c times, and we check if it is larger than the divisor. Now the trick here is if the dividend by shifted right for c times is larger or equal to the divisor, then it is also true that if the divisor is shifted leftward for c times, then it will be smaller or equal to the dividend itself, which means by checking this, we know already how many times the divisor needs to be doubled such that it can still be smaller than the dividend, and we can take that amount out of the dividend. So this is exactly what we did, right? We make sure that this is larger, the number of times that we need to shift the dividend. Then we shift the divisor again leftward. We just make the divisor bigger, and then we remove it from the dividend. And of course, every time our Q is going to be accumulated by this amount of times that the divisor has to be multiplied. So it's very, very sweet because these shifting things are very fast, and you can consider all of them O1, and the range is is also it's very fast. So in total, because we are not doing like multiple loops and stuff, this solution is very fast. So that is the thing that we were missing from yesterday. Okay, so let's try it today. All right, let's take a look. Maximum frequency stack. What is this? Oh, a lot of words. Oh, this is going to be a calling. Okay. Implement frequency stack, a class which simulates the operation of a stack-like data structure. It has two functions: push, I'm going to push integer onto the stack, and pop, which removes and returns the most frequent element in the stack. If there is a tie, then the element closest to the top of the stack is removed and returned. Okay, So frequency stack, push, 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 pop, pop, pop. So 5, 7, 5, 7, 4, 5. That's the push. Now we pop. So we pop 5. 5 is a most frequent. Oh wait, no. It's not pop on the top. It's to pop the most frequent one. So okay, so we have 3, 5. So we pop 5 first, then we pop again. We have 5 and 7. Both are 2 times, but 7 is closer to the top. So we pop 7 and pop 5 and pop 4 because they all have 1s. So we pop 4. All right. Push the integer, guaranteed pop will be called if the stack will not be called if the stack has 0 elements. So we don't have to check that, which is good. The total number of push will not exceed 10,000, and a pop will not exceed 10,000. Which means you cannot do a search through, which means it cannot be n squared, O(n) squared. Total number will not exceed 15,000 across all test cases. Alright, so we just have to implement it. So basically, what I'm thinking is that probably there's a heap inside the stack. And the push, we can keep pushing, but instead of pushing into a stack, we're actually pushing into a heap. And the heap will keep track on the frequency. So basically, when we push in, when we push in, how do we, so do we have to create another class inside? So every time, no. Frequency, or it could be a dictionary, right? Every time we push, we have a dictionary and we increment. However, the problem is, how do we constantly maintain the value with the most frequency on the top? This has to be a heap. But when we push, how do we push a value so that the heap can be optimized? We just have to do heapify every single time, right? We have to do heapify every single time that we, hold on. So we need a connection between the heap and the value that's pushed in. How do we do that? So the heap is just an array, right? And an array, we cannot do. No, we cannot do it that way. Can we just, so how long is heapify going to take? Heapify is O(n), right? So I push, and I push it again, right? So hold up. So I push, right? I keep a dictionary which tells me the frequency. So when I push a value, the dictionary will increment. And then I push the value into the heap. Now when I push into the heap, it's going to be a tuple. The first one will be the frequency, and it's actually going to be a negative frequency because the heap queue in Python is a min heap. So it's going to be a negative frequency. So after I push everything, the heap will have all of these values, but each one is associated with a different frequency. So when we pop, we will pop the ones with the least, with the most frequency. That is good. After we pop, that's good. After we pop, we update the dictionary, and we don't have to update everything else because they have the frequency associated with them, which is correct. It's the current frequency. Okay, that problem is actually solved. What is not solved is the position. So we need two things, right? So it's going to be a tuple of 3 values. It's going to be the first is the frequency, and the second is closeness to the top, which is the index. Also the negative index, because we want the ones that's at top of the heap to be top of the stack to be pushed, to be popped out first, which I think we can do. Okay, let's try this. I think we have a fairly clear roadmap to move forward, and we can do it pretty much directly. But first of all, we need to import heap q, and when we initiate, it has to be a what should we call it? We just call it heap. It has to be like this, and we have to have a map, which I don't like to call it map, frequency, right? This is going to be a dictionary, and there's not going to be a stack, to be honest. There's no stack. So when we push, right, what we're going to do is actually, instead of this, we can actually make that into a collections import default dict, because when we don't have anything, it is always going to be 0, right? It's going to be 0. So, or not 0, it's going to be int. So when we push, we're going to call self.frequency x plus equal 1, right? So we increment the frequency, and then we're going to push something into the heap. So we're going to call, oh, how about the index? We have to use an index. Well, we don't need an index, because do we need an index? Let me think. Because if the index is when we push it in, if every time we push in and we attach a number to it, right? So we attach a number and then push it in, and then we start popping, and then push in again. Even though it's not a current index inside this heap that we're using to simulate as a stack, but it still represents the relative positioning of the. So it's fine. It's fine. So we do need to have a counter. So we have to have a counter equals 0. I do not like to write counter. Let's write, yeah, let's write this. So it's going to be 0, right? So self.counter gonna always increment. Always increment. Do we decrement? Oh, we can decrement. Yes, every time we pop, we decrement the counter. That counter is the current. Oh, then we don't need a counter. It's just the length. It's just the length. Yes, we don't need a counter. We just need the length. So we increment the frequency, then we're going to push into the heap. So we need to know, what we need to know is, so we're going to do heap q dot heap push, right? And we're going to push the heap and item. So the heap is going to be self.heap, and the item is going to be a tuple, with the first one being minus self.frequency x. The second one will be len self.heap, is the current position. That also going to be a negative, because we want to pop out the first one. And the third one is x. Right, so that is the value we push into the heap. And after we push, then we're done. When we pop, we're going to pop out the first one. So we're going to just be this. No. Val equals heap q dot pop. No, it's going to be heap pop. Self dot heap. That's it. So we get a value. But before we return it, we need to do some things like self.frequency val minus equals 1, right? And nothing else actually is needed. So I think we can try this. can give this a shot and see if it works. Let's try run the code. See if anything goes wrong. Our answer get us none, 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 none. All right, something is very wrong. Something is very wrong. What is going on? I probably have to debug it here. I don't think we can do it here. We actually can. We actually can, but it's going to be different. Hold a sec. Hold a sec. Do we do the heap push wrong or the heap pop wrong? Oh, we didn't return. That's why it is returning none. All right, this one looks good. Yeah, let's submit it. I have confidence. And the confidence is not correct. And we got a wrong answer. All right, we need to figure out a way to test this. So how do we test this? It's pretty hard to test. We have to use this platform to test. So apparently, I don't know. I don't know what went wrong. I think something is wrong is when push and pop is yeah, actually I saw it already. I cannot deny that I saw that the problem probably is our push and pop is when it's mixed up, it's kind of not right. So for example, if I got push 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 and then pop, so we got push push push. What if we pop here? Push 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 pop, right? And then push push push. So we put like 6 here, and then pop pop pop. Let's see if this one gives us a good result. This one still do. All right. Do we want to investigate the wrong answer? I kind of don't want to. I want to try to figure out what went wrong here. All right. So how about we push in different values? I'm just trying different things. It seems to be still correct. Oh, okay. I give up. Let's see. So when we pop first one, 4 gets popped out. 4 is the most frequent. That's cool. And the next it should pop out 2, but I pop out 6. Oh no, it should be popping out 6, but I pop out 2. I kind of know. So closest to the top, I am currently using the length of the heap as the indicator. So every time we push in the length, right? So when we pop out 4, so if we think about it, it's 0, 1, 2, 3, 4, 5, right? So when we pop out and I push in 6 and then pop, why 2 came out instead of 6? Does 2 does not have a... Oh, hold on. Yes, because we have 1, 2, 3, 0, 1, 2, 3, 4, 5. So 2 has 5. The ID associated with 2 is 5. When I pop out 4, and then it's become the length decreases. So when 6 pops and goes in, then 6 has the same label, has same index as 2. That's what is wrong, which means we do have to have a counter. So unfortunately, we do have a counter, although initially I don't want to do it. So every time we push, counter should be incrementing, and we are not decrementing the counter because we have to identify which one goes later, which one goes first. So the counter always increment, and instead of calling this this is going to be calling self.counter. So this just counts how many times number has been pushed in. So we are going to change this. First of all, we're going to run the regular code that we have so far, just make sure everything works. And we're going to run this test case and see if this test case passes. I have confidence that this test case shall pass. We get 6 out first. Let's just show diff, kind of see, okay, I think it's correct. Let's try it again. And we have passed. All right, so the pain point that we had is I tried not to use another variable because I thought using the length of heap was enough to signify the current position in the stack of the current value, the newly pushed in value. However, I forgot that as the value gets popped out of the heap size decreases, which means the newly added value, its index could actually overlap the ones that's been pushed in before. So to resolve this issue, we do have to use a counter to just keep counting. So that is the solution. Any way to make it look better? I do not think so. I think this is how this one will look. Yeah, I think, man, we can probably make this in one line. I'm not sure if it can fit. That's why I did it the other way first. But apparently we can. Okay, can. So, and we're gonna pop this. Yeah, that's about it. I think that's pretty good. We're gonna take a look at our runtime. Yeah, it's about all right. It's all right. So we're using so we can just write our comment. Use a heap to manage the order of the variables, of the values in the stack. The criteria of ordering is the frequency followed by the position in the stack. Frequency, I cannot fit. Frequency is recorded, is tracked by a separate dictionary, while position is tracked by a counter. Each value in the stack, in the heap stack, is a tuple of frequency, position, and the value. And actually, I will have to mention these both are negative. And note that both frequency and position are negative values because we use a min heap. For each push, the runtime is O log n. For each push and pop, the runtime is O log n. And our overall runtime is 332, and we are at 41% ranking. All right, so we're done with this. We didn't use any of this, so we can comment it out. And we are going to check the solution. I think we had complete the entire, yeah, we did the entire February. Very good, very nice. So I go back to the question and see if they have a solution associated with it. Yes, there is. So we can take a look at the solution. This seems to be a easy one or a medium one. Huh. It's a hard one. Well, this is one of the fastest I've ever solved a hard question. I think we did it in like 20 minutes. I mean, including me explaining what we kind of missed from yesterday. All right, so well, I am surprised. I thought this is a medium to easy one. I mean, it's not that hard for me today, is because the idea of using a heap is just immediate. As I was reading about it, the idea of using it is just immediately pop into my mind, and I know pretty well how the heap works in Python. In fact, I answered a question on Stack Overflow with heap, which is my best answer. The answer received the most upvotes, so I guess that's why heap just becomes very second nature to me in this case. Okay, let's take a look. Approach 1, stack of stacks. Okay. Oh wow, it's actually better. Oh my god, we have log n, they have only O1. Doubly linked list. Stack of stack. Map of stacks. Huh. Alright. 2 stacks. Okay, I'm not reading it so far because I want to think about it. What do you mean by stack of stack? So apparently, we can maintain 1 stack of the current position. All right. Do we have another stack to maintain the frequency? Is that what it's talking about? A stack of stack? Hold on, a stack of stacks. So we have a stack, right? And okay. What I'm imagining right now is a stack, and within each stack, within this stack, we have values. No. Oh, wow. All right, I need to take a look. Frequency, okay, be a map from X. So we have the frequency, okay, that's the same. Current maximum frequency of any element. It's clear because we must pop the element within, okay. Among elements with the same frequency, how do we know which element is the most recent? That's using a heap. We can solve this. We can use a stack to query this information. The top of the stack is the most recent. True. To this end, let group be a map from frequency. A map from frequency to a stack of elements with that frequency. We now have all the required components. So they are having a stack of elements with that frequency. So we have the frequency. So I have frequency 5, and then in the frequency 5, I have, so frequency 5 is a map, the mapping, it's a dictionary. So the key is the frequency, and the value is, yeah, I'm still not looking. I'm still thinking. So the key is the frequency, and the value is a stack which records when the number, when the value like of that frequency gets hit. Okay? So we're onto something. So this is going to be a I will use a dictionary for this. So which means we have a frequency mapping just to keep count of frequency, and every time the frequency is hit, we push into, oh my goodness, this is a good solution. Yes, I think I know what it's talking about. We can implement it before we read the answer. That is a good one. It's a very good one. I see the beauty of it. So we don't need a heap, right? It's going to be a frequency, and we have a frequency stack. It's going to be a default digit as well, but it's going to be a list. We don't need counter. So we're going to call it f stack. F stack. I kind of like just to maintain them four letters, f stack, right? So push, of course, so we're going to increment this, but then, oh my god, this is so good. And then what we're going to do, we're going to say self.fstack frequency x, right? Frequency x, frequency x dot push, not push, append x, right? But hold on, how do you know what is the maximum frequency right now? How do you know that? How do you know that exactly? How do we know the current max frequency? The current max frequency. Because the frequency stack is not going to be a dictionary. It has to be a stack as well. So the top frequency will always be on the top. But what if I have a value that frequency 1, frequency 2, and then I have frequency 3, I push on top, frequency 4, right? And I have frequency 3, I can go back to 3. So this is not a dictionary here. I think this is just going to be a list of lists. I think that's what it is. It's going to be a list of lists. It's a frequency stack. So we on the top of the frequency stack is all the values with the top frequency, with a max frequency. And we can use the index. We can use the index to find the stack with the current frequencies. Yes, exactly. I think, no, this is not going to be a default. This is just going to be a list. Right? So we have this. And what we're going to do is we are going to say, what are we saying? I mean, let's go back to the description. The description says the total number of push calls will not exceed 10,000. All right, which means we can let's just append, right? Every time, like if I say if not self f stack, so this is the beginning, right? Then we just self.fstack append what? We're gonna append a no. It's gonna be if len, right? The length is equal to self.frequency x. That means if the length is equal, that means that frequency has not occurred before. Therefore, we need to add a new stack into this stack of stack. And then we can say if stack this dot append x. That's exactly true. That's exactly true. And after we do this, then we can pop. What we can do is we can pop the top. So what we're going to do, we're going to check the top of the frequency. I'll be back. All right, let's continue. Where are we? So where we go? We're gonna pop now. So when we pop, what we're gonna do is we're gonna find the top of the frequency. So we're gonna find the top of the frequency, and we're gonna pop the value. So we're gonna say value equals self dot f stack minus 1. That's the top stack dot pop. So when we pop, it will be the closest to the top. Okay. So after we pop, we need to check if not self dot f stack. If the top becomes empty, then we need to pop it, because if we do not pop, oh, we do not need to pop. Why do we need to pop? Yes, we do need to pop because we need to always look at the top. So the top has to be always valid. So if the stack, then we're gonna say this one gonna pop, and we're gonna return val. All right, this is very exciting. I think this one will work as well. Let's give it a run. And we hit an issue saying it's out of range. Why? I say if the length, oh, this is 0. Initial length is 0. So, which means I have to say if it's smaller. It's not equal, it's smaller. Because the length, a better one, minus 1. Because minus 1 is the actual position that we're gonna push it in. It's gonna be minus 1, which is smaller. So we can actually change it to smaller. So we're gonna change it to smaller. So this one's correct, but we will change it to smaller. So we'll make it easier. Okay, let's try it. Runtime error. List out of range. We have a list out of range again. That is very interesting. We have another list out of range. Okay. Why? If my length is smaller, right, then I append it. Now my length is equal. Then if I do this, it shall not. Why would it cause this trouble? So I push. All these are 1, right? So frequency all increments. So full frequency is 1, and I append another stack, and I do 0, right? Dot append x, which is correct, and I push again 0, which is also 1. So I append 0 to it. So 9, 3 is all good. And I'll do 4 again. 4 again. And 4 increment. Now full frequency becomes 2. But this one is 1, smaller than 2. So I'll add another 1. And then this going to be 2 minus 1 is 1, which is correct. And 2 shall also be pushed in. Now when we pop, we pop the top, which means we pop this 4, right? And then we pop it, and then become 1 again, and get a 6. Why would it be wrong? It's a list out of range. Okay, so don't worry. Let's now take a look. We can print self.fstack. I think this is the main thing. And let's see when we have the issue. Okay. And 4, that's good, that's good, that's good. And then we push 2 again, yes. And we pop, that's good. Oh, it's not here. So we pop and we push 6, that's correct. And we push 1. Okay, hold it here. We pop here, we pop 4, we push 6. And do we have a pop again? Oh, it pop 6. Okay, 6 get popped. And we push 1. And we pop 1. Oh! I forgot a decrement. A value gets popped. And I forgot a decrement self.frequency. Yeah, it was my fault. Yeah, that shall do. Oh, I should remove this as well. That shall do. Yep, this one shall work. Yes. Oh, ooh, so much faster. So much faster. Oh, this is a good solution. Very good. Well, we did it without looking at the solution, but now we're going to take a look at the solution. See if we have frequency. Have a counter. They use a dict. Okay. We did not use a dict. +1. Yeah. F equals dict. Okay, that's fine. Larger than max frequency. Oh, yeah, keep check on the max frequency. We don't have to. We don't have to check on the max frequency. We use the length to do that. Yeah, it's the same. It's the same solution. Same solution, and they use a max frequency to check. We do not. We just use the length to check. All right, that's a good solution. Yeah. This is the standard solution. Official. That's how I would like to call it. Official solution, and it is very, very smart. It uses a stack of stack, which is self.fstack to record the order of frequency. So each position in self.fstack each position represents the values that currently have the corresponding. Yeah, it's hard to explain. Let me say, for instance, that's example is the best. For instance, at position 2 of self.fstack, we have all the values with frequency 2 plus 1 equals 3. And all these values are stored in yet another stack with the order of appearance. Therefore, when we pop, we only need to pop the top of self.fstack because the most frequent values are stored there. And within self.fstack -1, we always pop. We can always pop the top because the values in self.f stack -1 are pushed in according to their appearances. This is a very smart solution, and it runs in O1 time. So it's also faster than my heap solution. It runs. The runtime is a whopping. The runtime is 288 milliseconds, or 97% ranking. Bravo, muy bravo. All right, just a final check. Python 01, yeah. Push pop. Yeah, it uses max. Anyway, so I think it's Python priority queue. Yep. Yeah. This is my solution. Oh my god, probably exactly the same. Oh my goodness, it's exactly the same. Yeah, it is. It is. Oh, it's almost the same, but it's good. Yeah. I'm gonna write this. This is the most natural solution. How should I say that? I want to say like this is like the first solution you can come up with, right? Natural solution to come up with. This is probably the most natural solution to come up with in an interview. With most natural solution to come up with in the first attempt. I can imagine this question. Can imagine this question be asked in an interview, and a candidate is able to provide the heap solution in like 10 to 20 minutes. Then a follow-up question can be asked regarding whether the performance can be further improved in the first attempt. Imagine this question be asked in an interview, and the candidate shall be able to provide a heap solution in 10 to 20 minutes. And then a follow-up question will be asked regarding whether the performance can be further improved. And this is the hard part. But with a bit of hint from the interviewer, such as, have you thought about a stack of stack? I expect candidate. I expect that a candidate should be able to reason about, to be able to find the O1 solution in another 10 to 20 minutes. Yeah, that's. In summary, I think this is a very good question for interview. I'm actually going to bookmark this one. This is a very good question for interview. How do I bookmark it? I might actually use it in the future. Add to list. I don't know, create one. Good interview questions. Create. And I do not want to put in favorite. Done. So we have, how do I check my list? My list. Good interview questions. I can make it public, it's fine. Nightmare. Oh yeah, I have nightmare as well. I don't have favorites. No, I don't have favorites. Alright, so that'll be it. It's a very good question. Like I said, I think this is a very good question for interviews if you have not done it before, because you shall be able to come up with a heap solution very fast. I mean, fast relatively. I said 10 to 20 minutes. And then with some prodding, some help, you shall be able to come up with a stack of stack solution. I'm considering it completely based on my performance, and I expect a candidate shall be able to at least, I mean, you have to come up with this anyway, right? And then with some help, you might be able to come up with this. All right, that will be it for today. We handled a hard question pretty well. I am very proud of myself. All right, that's it. That's it for today. I'll see you guys tomorrow. Adios.